So this is the mark scheme for the AS exam. For those of you who sat the exam with modifications from Group A, there will be a couple of questions that are slightly different or that have been taken out. Don't worry about those, you can still skip ahead to the questions that you have done in your exam. Just to begin with the multiple choice questions, the first question here assesses your knowledge of atomic structure. You have been given the structure Cl- with a mass of 37. The first thing is you should look for chlorine on the periodic table and identify its atomic number. Now, atomic number refers to the number of protons in the atom. So immediately you should identify that chlorine has 17 protons. That narrows down our answer to two possible combinations, which are A and B, because both of those two have 17 protons in. To get the number of neutrons, we can work that out by doing the mass number take away the atomic number. So 37 take away 17 would give you a mass of 20, which means that your actual answer is B. Moving on. What is the formula of ammonium sulfide? Well, to do this type of question, you need to know the formulas of the ammonium ion and the sulfide ion. Now, ammonium is NH4 plus, and sulfide is S2 minus. Now, in order to get the formula, you need to balance the charges. So because S is 2 minus, that means you need two NH4s in order to balance the charge, and therefore the formula should be NH4 2S. And question 3, in order to do this correctly, what you need to understand is, one, there is a mole ratio in the equation, and firstly, that mole ratio is 1 mole of solid, which goes to 2.5 moles of gas. That is the 2 moles of NO2 and the half a mole of oxygen gas. So because of that 1 to 2.5 ratio, you do 0.005 multiplied by 2.5, which gives you the moles 0.0125, and then we have to multiply that by the volume that 1 mole of gas occupies at room temperature and pressure, which is 24,000 centimeters cubed. When you do that times 24,000, you get a volume of 300, which is answer D. Okay, in question 4, you're asked which of these reactions is not a neutralization reaction. At this point, the two neutralization reactions that you should be aware of are an acid plus an alkali and an acid plus a carbonate, both of which produce a salt at the end, or a salt and water. Now, of these three here, there are two reactions, which are acid plus alkali or acid plus carbonate. B is an acid plus an alkali, C is an acid plus a carbonate, and D is also an acid plus an alkali, but because of the lack of oxygen in a weak alkali like ammonia, then you can't form water at the end. That means that the only suggestible answer for part 4 would be the reaction between calcium and hydrochloric acid. The oxidation number of nitrogen MgNO32, it basically works out as an algebraic equation. The first thing is, we know that the nitrate ion is NO3 minus. So we know that NO3 has a -1 charge. And basically what you have to do now is do a little bit of rearranging. We want to know nitrogen, so let's say nitrogen is X, plus we have 3 lots of oxygen. The oxidation state of oxygen is -2, and that equals -1 as the answer. If you rearrange that equation, that shows that X is +5, and therefore C is the answer. Finally, how many orbitals are occupied in a silicon atom? This comes down to understanding the electron configurations of silicon and how electrons are organised in terms of orbitals. Now, the electron configuration of silicon is 1s2, 2s2, 2p6, 3s2, 3p2. Now, up to this point, what we have is we know that any s subshell contains one s orbital, and all of those have been filled so far. Any p subshell contains 3 orbitals, like that there, including the 3p orbital, 3p subshell at the top here. But there's only 2 electrons in the 3p subshell, and remember that they're arranged so that the electrons occupy individual orbitals first. So in total, that will be 8 orbitals that have been occupied. So the first 2 s orbitals, then an additional 3 from 2p6, another from 3s2, and then finally you've got 2 of the occupied orbitals in 3p2, which means that your answer is C. Okay, moving on to question 7. This here is NCl3. As you can see from the diagram, it has 3 bonded pairs of electrons. Those bonded pairs are located here, here, and here. It also has a lone pair, and that lone pair is at the top. Remember that lone pairs do repel more than bonded pairs of electrons. If you have 4 pairs of electrons, the bond angle is 109.5, minus 2.5 for every lone pair that you have. So if you take 2.5 away from this, you end up with 107 degrees. And that narrows down your answer immediately to either B, pyramidal, or C, tetrahedral. Now, tetrahedral is where you have 4 bonded pairs, no lone pairs. So your actual answer is just pyramidal, 107 degrees. Graphene is one of the giant covalent structures that you do need to know for the course, and graphene basically has a carbon structure where there are 3 bonds and 1 free electron, and for that reason, because there are 3 bonds, no lone pairs, it is a trigonal planar shape as your answer. Question 9 here. Question 9 asks which of these electron configurations represents the element with the largest first ionization energy. The first thing I would say is that this depends on the number of protons in the nucleus and also on the shielding in the atom. Now, shielding takes priority first, and because the lower the shielding, the more difficult it is to remove the electron, and therefore the higher the ionization energy, I would immediately discount option D, because that has 3 shells as opposed to the 2 shells in the other two. At this point, you're just looking at the number of protons in the nucleus. Because the number of protons and the number of electrons are equal, then C has the most protons and therefore will have the greatest attraction between the nucleus and the outermost electron. And question 10 here. In any question like this where you are comparing successive ionization energies, what you're effectively looking for is the biggest jump to be between the group number of the element in question, in this case magnesium. Magnesium is in group 2, and the next number up, which would be 3. So you're looking for the biggest jump between the second and third columns. And if you have a look at the second and third columns here, you will see that the greatest jump between 2 and 3 here would be found at B, where it jumps from 1451 to 7733. So that's the biggest change in energy. Okay, question 11. The reaction here is actually 2 reactions, one in each test tube. You're going to be adding dilute sulfuric acid to a solution of sodium carbonate and also to a solution of silver nitrate. Treat each of these 2 equations separately just to begin with, and we're going to think about the reaction with sodium carbonate first. When you add an acid to sodium carbonate, you should get the reaction where a salt, water and carbon dioxide are produced, which means that you narrow down your answer immediately to C and D, because those are the 2 with effervescence. Now, when you add sulfuric acid to aqueous silver nitrate, you produce silver sulfate as a precipitate. Now, because silver sulfate is a precipitate and you're going to get effervescence, the correct answer must be not C, but D. Question 12 here involves understanding how to set up a Hess cycle. Now, it's important to recognise that a Hess cycle depends on the data you are given rather than the equation in question. So even though this is an enthalpy of formation equation, the data that we are given is enthalpy of combustion. And that is how you determine whether or not the arrows are going to be pointing upwards or downwards. Because it's an enthalpy of combustion data we are given, then the arrows will point down, like that there. And the sum that you get is 4 times the enthalpy of carbon. Now I'm not going to put the numbers in here. Plus 5 times the enthalpy of hydrogen. And then, because we're going against the arrow, so we're going to go down this arrow first, and then we're going to go against this arrow to go up here. Because we go against that arrow, we have to swap the sign. So currently that sign is minus 2877. We are going to plus 2877. And if you add those 2 values together, once you've put the numbers in, you should get a final answer of minus 129 as your result. So the answer should be B. The next part, comparing structural isomers. The easiest thing to do is to identify the number of carbons, hydrogens and oxygens in each of the molecules. What you'll very quickly identify is that E is C5H12O. So we'll put that. Oops, we'll put that on here. So C5H12O. If we work down, G is also C5H12O. And the other two, if you have a look, 1, 2, 3, 4, 5, 6 carbons at the top here. So this would be C6H3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. C6H14O. And because there's a double bond in this one at the bottom here, and there are a total of 5 carbon atoms, this will be C5H10O. Now, structural isomers have the same molecular formula, but a different structural formula. The only two with the correct structural formula here are G and E, and therefore our correct answer is B. Okay, with question 14 here, the easiest thing to do is to identify the longest carbon chain in the molecule first, which is this here. Then everything else coming off that is a side chain, so we've got 2 chlorines and a CH3 group here, all of which are side chains. Because there's 4 carbons in the main chain, that makes the name of the molecule based on butane, and for that reason that narrows it down to C and D. The next thing is that we have to make sure that the molecule has the lowest numbers possible within the name. So if you have a look at C and D, C has a combination of 2, 3, 2, and D has a combination of 2, 3, 3. The lowest total number is the correct answer, and therefore C would be the right answer. The next question is quite difficult in terms of what you need to know, so it's easiest to draw out each molecule in skeletal formula. So E12-dichlorobutene, well, there is E-butene, and we've got 1,2-dichloro, so we've got the Cl's here and here. Your E23-dichlorobutene would be here like this. You then have Z23-dichlorobutene. I'll just try and move that down a little bit. There we go. So when you're drawing the Z isomer, it would look like that there. And then we've got the 2,3-dichloro, so that will be here and here. And then finally, you've got the Z14-dichloro, so that would go here and here. Now, what you'll notice is that there's only one of these 4 molecules that has the chlorines on opposite sides of the molecule. Okay, that molecule is this one here. So this would be non-polar because both sides of the molecule have delta negative on it, whereas the rest would only have delta negative on one side because both chlorines are on either the top or the bottom of the molecule. Question 16. It's important to know that every single bond, whether single, double or triple, contains a sigma bond, and that double bonds contain a sigma and a pi bond. So with that in mind, if you count up every single bond within the molecule, you'll very quickly identify that there are 12 bonds, and therefore there are 12 sigma bonds which means that your answer has to be D. But just for clarity's sake, because there are two double bonds, that means there would also be two pi bonds as well, which doubly proves your answer at the end. Now, question 17 is to do with propagation steps. Remember that a propagation step is always going from a radical and a non-radical to form another radical and a non-radical. So immediately that narrows down your answer to either C or D, because both of the other steps either has two radicals or no radicals at all. Now, what you have to remember with propagation steps is that the chlorine radical or the halogen radical will always steal a hydrogen from the alkane molecule, and therefore the only correct answer can be D. Okay, the key part of this question is to identify something that forms a ketone. Immediately what should come to mind is that you can only oxidize a secondary alcohol to become a ketone. And if you look carefully through the structures, there is only one alcohol group that has only two R groups attached to it, and that is B here, because this carbon atom here has only two carbon atoms attached to it. So that immediately proves that that is your secondary alcohol and therefore can form a ketone. For question 19, you have to understand your mechanisms. The first thing is you need to identify that this reaction is an alkene reacting. Alkenes only ever react by electrophilic addition, and therefore you can narrow down your answer to either A or B. The next thing is that your second reaction is the reaction of a haloalkane to form an alcohol. And again, haloalkanes only ever undergo two types of reaction, either elimination or nucleophilic substitution. Because your options within the question are either electrophilic substitution or nucleophilic substitution, then there's only one possible answer that you can have, and that answer should be option B. Finally, it's important to know the importance of bond strength for this. So I think I've spoke about it a couple of times. The CCl bond length is quite short in comparison to the Ci bond length, which is much longer, because the iodine atom is far bigger than Cl. That means the bond is longer, and the longer a bond is, the weaker the bond is, and therefore the lower the bond enthalpy will be. And so Ci is the weakest bond, and therefore Ci requires less energy to break than the CCl bond. Okay, for question 21, what you have to do is analyse the similarities and differences between atoms of the same isotope. So the similarities that they have are the number of protons and electrons. The differences is the number of neutrons. Okay, so that's your answer to get 2 marks for this part. So the number of protons, electrons, and the number of neutrons. To do this calculation, what you have to do is multiply the relative abundance by the mass of that isotope and add that to the relative abundance multiplied by the mass of the second isotope. Once you've got those two values, if you divide by 100, that will get you to your final answer, and that should be 63.62. This is a bit more of a difficult calculation. There's quite a few steps to it. The first thing is you need to work out what 84% of 5 grams is. If you do that, you should get 4.2 grams. That is the mass of 84% of the coin. Then you would have to work out the moles of copper in the coin. So you would do 4.2 grams divided by your molecular mass that you calculated in the previous question, 63.62, and that will give us the moles. If you've done that correctly, you should get 0.06 moles. And then finally, to get the number of particles, you take the moles and you multiply by Avogadro's number. That number is on your data sheet. It is 6.02 times 10 to the 23, and ultimately what this gives you is the number of particles in the number of copper atoms in one coin, and that should be 3.97 times 10 to the 22. As your final answer. Writing the equations here should be easy enough. For this reaction, the reaction should be nickel oxide, which is NiO, reacting with 2 lots of sulfuric acid, and that will form your nickel nitrate, which is NiNO3 and water, H2O. And that is your balanced equation. Moving on to the dot cross diagram. Now, this here was a broken question on a couple of people's exams, but if it wasn't and you did this question, then the way it should look is you should have your nitrogen atom in the centre, and it has, as you can see from the diagram above, a covalent bond to O- at the top. Because it's a covalent bond, it has a shared pair of electrons, with 1 electron from each atom. And then oxygen has, because it's negatively charged, 7 of its own electrons. So we'll illustrate those as dots around the oxygen, like that. Then to the bottom left corner you have a double bond, which means that you have 2 electrons from nitrogen and 2 from oxygen. This oxygen atom then has a further 4 electrons of its own, like that there. And finally you have a dative covalent bond, which means that you have 2 electrons which come from the nitrogen, because the arrow is pointing away from the nitrogen, to the oxygen atom. That oxygen has 6 electrons of its own. And that there, once you've put the brackets around it and the negative charge in the top corner, should be your dot cross diagram for the nitrate ion. Okay, in our next question what we need to do is calculate the minimum volume of sulfuric acid required to react with sodium hydroxide. Now, in the common way that I tend to do this, I'll set it out in a table with a volume. Actually, I'll change all of this. Okay, in the common way that I tend to do these questions, I've set it out so that you have a table to fill in all of your information. From the question, if we highlight the information that we are given, we're told that the 6.25 times 10 to the minus 2 centimeters cubed of sulfuric acid. Sorry, 6.25 times 10 to the minus 2 moles per decimeter cubed sulfuric acid is added from a burette to 25 centimeters cubed of 0.124 moles per decimeter cubed sodium hydroxide. Now, we're going to put that information into the table. The first thing is, we know that the sodium hydroxide is 25 centimeters cubed, so that will be 25 over 1000. Okay. The concentration is 0.124. And the ratio between the two is 2 sodium hydroxides to 1 H2SO4. Now, we also know that the concentration is 6.25 times 10 to the minus 2, or 0.0625. And we can work from here in order to calculate the moles of sodium hydroxide, the moles of sulfuric acid, and therefore the volume of H2SO4. The moles of your sodium hydroxide should work out to be 0.0031, or 3.1 times 10 to the minus 3. 0.0031. Because that is in a 2 to 1 ratio, we have to divide by 2, and that gets us 0.00155. There we go. And then what we can do is multiply the moles by concentration to get volume over 1000, and that works out as 0.0248. And because that is volume divided by 1000, we then need to multiply by 1000 to get it into the correct units, which means that your volume is 24.8 centimeters cubed. With regards to the next question, you need to be able to identify the oxidation states of a number of different elements. The first one is aluminium. Now, on the left hand side of the equation, aluminium is in its elemental form and therefore has an oxidation state of 0. On the right hand side, aluminium is in aluminium sulfate. Because we know that the sulfate ion is 2 minus, and there are 3 of those, then both aluminiums together must be plus 6, and therefore one aluminium will be plus 3. I think a number of you in the end forgot to divide by 2 and they put 0 to plus 6 as your answer. For hydrogen, hydrogen is in H2SO4 to begin with, and therefore hydrogen starts off as a plus 1 ion, and because it is in its elemental form at the end, elemental form means it has an oxidation state of 0. Right, moving on to question 23. The electron configuration of bromine, you should write it out in full. I'm going to write it out in the shorthand method. Should be argon, so that represents all of the electrons up to argon, which is 1s2, 2s2, 2p6, 3s2, 3p6. We then continue with 4s2, 3d10, and then 4p6. And that is your full electron configuration. Remember that rather than shortcutting it, you should be writing out this in full. Just that I didn't have enough room to do that. In terms of reactivity, you should know that Cl2 is more reactive. And the equation is Cl2 plus Br minus, and there should be two of those, goes to 2Cl minus plus Br2. And that is because chlorine reacts with the bromide ions and takes the electrons in order to do a little bit of a redox reaction there. One benefit and one risk of chlorine in water treatment. The benefit is that it kills bacteria. Okay, and the risk is that it is toxic in high concentrations. The reagent needed to test for the halide ions is silver nitrate, or just AgNO3. And the precipitates that come along with that are white, cream, and yellow. Okay, the next question is our enthalpy change question, so Q equals mc delta T. The first thing to note is that the mass of water is equal to the total volume of water, and in this case, because you have two volumes of 50, the total is 100 centimeters cubed. You multiply that by the specific heat capacity of water, which is 4.18, and then that is multiplied in turn by the temperature change, which you should have calculated to be 10.5. That gives you Q, and the value for Q should be 4389. Like that there. And therefore in kilojoules that would be 4.389. What we then need to do is calculate moles, and in the question you're told that one of the reactants is in excess, the other one isn't, and it is the limiting reagent we need to find the moles of, and therefore it is 1.5 multiplied by 50, so volume times concentration, divided by 1000. That gives you moles of 0.075. And then to calculate delta H, it is your Q divided by the moles, so 4.389 divided by 0.075, and that gives you a enthalpy change of 58.5 kilojoules per mole. However, because it is a temperature increase, we need to put a negative sign in here to show that that enthalpy change is exothermic. A lot of people made mistakes in this one because they forgot that the total volume here is 100 rather than 50, and so made that mistake there. ionic equation in this case. Ionic equation should just be the reaction of the lead ions, Pb2+. They react with 2I- to form Pbi. Now, it does ask for state symbols as well. The both of the original ions at the start are aqueous. And the lead iodide is a solid at the end. Apologies for that. There we go. So your lead iodide at the end, like I said, is a solid. Okay, the last part of the question is that you need to work out the concentration of potassium iodide, knowing that it was in excess by around about 10%. So for this question here, what we need to do is initially work out the moles of potassium iodide. Well, we know that potassium iodide is in a 2:1 ratio with lead nitrate, and we calculated the moles of lead nitrate in the previous question, and the moles of lead nitrate was 0.075. Because it's 2:1, we would multiply it by 2, and that gives us the moles 0.15. Once we've got the moles to be 0.15, we do moles times volume over 1,000, or moles times 1,000 divided by volume, and what that gives you that's times 1,000 divided by the volume, which is 50, and that gives you an answer of 3. Because your answer, your concentration was 10% higher than expected, you would then do 3 times 1.1, which gives you your concentration as 3.3. Right, in this written question, there are a number of different things that you need to include. The first, as you can tell by now, writing on here isn't easy. The first thing that you need to do is consider temperature. Now, for temperature, we need to know that first, the reaction is exothermic, and therefore, as you change the temperature of the reaction, equilibrium will shift to oppose the change. In this case, to maximise the yield, we'd want to use a low temperature, because that forces equilibrium to the right to maximise the yield. For pressure, we need to identify that there are 3 moles on the left hand side of the reaction, and that goes to 2 moles on the right hand side of the reaction. For this reason, it's important to use a high pressure in order to maximise the yield. Now, the last part of the question asks us to explain why in industry these conditions might not be met. There are a number of different answers. The easiest thing is to say that because we're using high pressures, so high pressure is dangerous because there's the risk of explosion. Also, it's more costly to use high pressure as well. So you've got a number of different answers that you could possibly have there. In part B, again, because it's worth 4 marks, you do have a number of different steps that you need to do. The first of which is to calculate the value of Kc. To use the value of Kc to explain where the position of equilibrium is. So Kc is less than 1, therefore equilibrium lies to the left. So equilibrium, EQM, lies to the left. Then we need to do a calculation. Now, the Kc expression for this reaction is Kc equals the concentration of SO3 squared divided by the concentration of SO2 squared multiplied by O2. What we need to do is then substitute the values in for SO2, O2 and Kc, and the rearranged equation leads you to find that SO3 squared equals Kc times SO2 squared times O2 Once you've substituted the values in and rearranged the equation, remember that because this is squared, we can therefore square root all of this. Your final answer should come out as 0.876. Okay, this compound here is an alkene, notably because of the double bond there. And the general formula for an alkene is CnH2n and to convert an alkene into an alkane you need to use H2 and a nickel catalyst. A lot of people got that wrong, putting a lot of strange, weird and wonderful answers, but that's something that you definitely have to learn. Okay, skeletal formula for this one. The key part here is this. There is no reaction when you try to oxidize this product, and that immediately suggests that it is a tertiary alcohol. And because it is a tertiary alcohol, what we have for the structure is CH3 attached to CH, like this, OH there, and 2 carbon groups off here. When that reaction is, when the other reaction takes place, where you form the alkene, you can then polymerize the alkene, and that will look like this. So you should have a carbon-carbon single bond in the middle with trailing bonds either side. Hydrogen on both bonds on the left-hand side. And on the right-hand side, you should have 2 CH3 groups. Like that there. There you go. So that should be the structure of your alkene, or your addition polymer. Empirical formula here, well, if you have a look and see if you can calculate the molecular formula comes out as C4H10O2. and as you know, that can be simplified down, and so your molecular formula becomes C2H5O. And last question. To convert your compound B through stage 1, to get all the way to your alcohol, you should be using bromine. So Br2. The reason you have to use bromine is because that adds the bromine onto both sides of the molecule. So you end up with your Br here, and 2 carbon chains, and a Br over here. And then when you react that with sodium hydroxide, that replaces the bromines with the OH group to form the alcohol.